For the student t-test, as we know, because the sample size is less than n is less than 60, we have to check if they met all assumptions and conditions. And in this case, we have independence assumptions, and then because normal population assumptions, this one is we can never be certain that the data are from the population that follows a normal model, but we can check the near normal condition. So the near normal condition, that's basically we can do is we using a checklist condition by making a histogram, box plot, or normal probability plots. And then for the smaller size, like n less than 15, we want the data is more closely follow normal model. And if n is between 15 to 40, also we say it's a moderate sample size. The t works well as long as the data are unimodal and reasonably symmetric. And for sample size larger than 40 or 50, then we can use the t methods. T methods are safe to use unless the data are extremely skewed. So for our example, this is using the software to check the assumptions. So basically we want to see the near normal condition was examined. And this one is we draw a histogram. So that's the histogram is a unimodal, and the box plots looks very symmetric, but there is a presence of two outliers, and this one were causing some troublesome. And in the mini tab, it also offers the Ryan-Joyner test and with the probability plots. So this is the probability plots, and the Ryan-Joyner values is calculated and the p-value is calculated. So this value is basically say this data is follow near normal condition. But in the Excel, we don't have the Ryan-Joyner factor, so we don't have this factor calculated. And what we do is we can do the histogram, box plots, and the probability plots. Let's take a look. Okay, just change a little bit on this way. So we already talked about to do the histogram and the box plots. We just select this column of data, and then we can do is we insert in Excel. We just select the data we want to do the plots. So just select these columns, and then we use insert. Put this one here, insert, and then here is a histogram, and this one is a box plots. I already done these two. That's introduced at the very beginning of this course. And this one is look at these two figures. It's also this one is a unimodal. It's close to symmetric, but there is two outliers. To do the probability plots, it's a little bit difficult because Excel does not have those functions. We just insert one columns here. So we do this one is first we want, you can see I already copy all the data on these columns, and we do this sorted data. So sorted data, and then we will put in the index I, and then we the third columns we just calculate the probability of this I. And then how we do this, each one is we start from this sorted data. So we just select this column of data, and then we see, just use a sort function. So that's the home. So at here, at home tab, there is a sort and a filter. So we just click this one, and we sort smallest to largest. We can sort this one. Continue with this current selection, so that we'll sort all the values on this column. And then we continue with this index I. So I will count 1, 2, 3, 4 until how many the sample size of n. So we only need to insert 2 values, so that's the trends. So once you select these 2, just drag this corner to all the way down here. So you can see this is the value 1, 2, 3 until the sample size 41, and then we calculate this probability of each value, probability of this I, and this one we goes to the we get a equation. So the equation calculated here is we use this value minus 0.5. Let's divide by count. U-N-T, count. So just count. So that's basically I can count this how many numbers here. Then just try to A to A. Just count original on this columns A, and insert this value. So that's once the equation is here, we just drag this one also down to the very bottom, number 41. So that's the just separate these two. That's the. So now we are trying to do the probability plots. So probability plots is basically we want this sorted data and this accumulation of the probability. These 2 columns. So just select these 2 columns. Just select this one. And we try to add another columns here. Press Control and then use your mouse to select the second columns. Control. Okay, so that's how we select all the data. And then next we just insert. We use scatter plots. And we just use the simple scatter plots. Simple scatter plot, the first one. So let's give us this scatter plots. So we just put this one a little bit on this way. So we just try to do this one. Same as before, we do some modification of this plot. So we get this one, double click. That this one format area, chart area will show here. And so we want to change the x-axis value. So just go to horizontal value axis, and then the last one here, axis options. We want to change values. So in this case, you can see we want from 6 to actually 12 is enough, but we can go up a little bit. So 6. The minimum change to 6 and the maximum 13. Yeah, 13 would be good. And of course, we can do some more modification on this one. So you click once on this figure, these 3 tabs will come out. So the first one, we want to show the trade lines. just trade lines. So you can go, if you click here, you can see we have linear trade lines, exponential, linear, forecasting. So we will choose this linear. If you want to change the style of this graph, we can get this one. It's this one, and then we do the. And then goes to, we change this one, and we want to see this one is probability plot of Humerus. Yes. Okay. So this file, that's basically will provide the normality, near normal condition check of this data, and we look at this figure. So I have another figure. Just take a look of how we determine if this one. Okay. So this figure is basically give us not only the data values and the near normal. That's the center line is a normal distribution lines, and this is data, another example's data's value located in this range, and the two side lines is basically draw the 95% confidence interval. So you can see in this case the middle points should be very close, but the two sides could go a little bit wider. So come back to our example. So this figure does not seem very worse than the normal distribution. Other than these two outliers, we see this one is close to meet the near normal condition. And go back to the notes. So this one is say we do the test, and it's we can assume this near normal condition is met in this case.